four main approaches: natural cleanup, containment and recovery, chemical dispersion, and shoreline cleanup. In many cases, a combination of all four will be required. This program deals with containment and recovery, an ingenious solution to a difficult problem. This rice straw and wire netting, although only a temporary answer, is providing one of the fundamental approaches to oil spill response: containment of the oil on the water surface for subsequent recovery. If oil is to be collected from the sea surface, some form of containment is necessary to prevent spreading. Once oil has spread and become viscous due to evaporation and mousse formation, the possibility of recovering it from the sea is reduced. Containment close to the source can not only localize a spill and reduce pollution, but it also facilitates the recovery of the oil by concentrating it in thicker layers on the surface. This can best be achieved by deflecting oil to a suitable collection point or containing the oil in a moored or towed boom. If a decision has been made to contain oil, a rapid response is essential. Equally important is the prompt removal of any oil contained. Booms can be constructed and deployed for oil containment and subsequent removal, or to divert the oil away from sensitive areas, such as these fish traps.
This diagram shows the mapping of sensitive coastal areas: marshes, fisheries, water intakes, and recreation beaches. With increasing time, an oil slick will tend to spread into thin films and break apart into smaller patches covering progressively larger areas. As the area covered by the spill increases, the cleanup operation becomes more difficult. Without the use of booms, the fate of an oil slick on this coastline could be projected like this. Booms and barriers deployed at the right time in strategic positions could protect some of these areas.
Unfortunately, this apparently obvious solution is not always so easy in practice. The limitations of booms are seldom appreciated, and the problems caused by the spreading of floating oil and by currents, tides, wind, and waves are usually underestimated. At sea, waves can make deployment and handling difficult. Poorly maintained or deployed booms are prone to failure, and multiple vessel operations can be difficult to coordinate. Even in calm sea conditions, the effects of currents can defy containment and recovery of oil. A correct mooring is not always easy, particularly with long lengths of boom. It's difficult for booms to remain equally effective at all stages of the tide, and access can be a problem. It's possible for many of these problems to be overcome by effective design and proper deployment. But it must be remembered that there is no one approach and design to fit all situations. This improvised boom has been constructed with indigenous materials and the ingenuity of the local people. When there is no commercial boom immediately available, constructions such as these can be fairly effective, especially with small spills in sheltered waters. In some situations, the shoreline itself, such as this sandbar, provides a natural barrier and prevents oil from reaching more sensitive areas. Barriers and booms, whether improvised on the spot or custom built, are important devices in any cleanup operation.
Although boom designs vary, most of them incorporate 5 features. A freeboard, the section above the water that prevents or reduces the oil splashing over the top. A means of flotation. This can be achieved by air or some buoyant material. A skirt, the section below the water that prevents or reduces the escape of oil underneath. Ballast, to hold down the skirt and keep the boom upright in the water. Strength, either incorporated in the fabric of the boom or as a chain or wire to withstand the effects of winds, waves, and currents. There are many individual designs of booms. Fence booms are usually relatively easy to deploy and reasonably robust, but less effective in waves and currents. Curtain booms tend to be more expensive, but in general have better oil retention characteristics, and with air flotation ride the waves well. Solid flotation booms are also robust, but are bulky in storage. All have their different advantages and disadvantages. But boom designs must always be a compromise between conflicting requirements: strength and weight, reliability, and ease of deployment.
Whatever types of boom deployed, their performance is greatly affected by wind, waves, and currents. These forces, singly or in combination, can often lead to loss of oil or boom failure. Currents can cause oil to escape under the boom. Wind or waves can cause splashover. The boom can fail mechanically, especially at the structural members or joints between the boom sections, and due to improper deployment in terms of anchoring, positioning, and sealing. Lack of consideration of currents and tides can result either in inefficient containment or loss of oil from within the boom. Correct procedures in deployment, anchoring, and positioning can be taught and rehearsed. But it's important to know the limitations of booms and barriers. To prevent booms from failing, regular monitoring and maintenance is essential.
Time, money, and effort can be saved by understanding the limitations of boom deployment. Booms placed in moving water tend to act as dams. Because the surface water and oil is held back, at a certain velocity it is diverted downwards and passes under the boom. This usually occurs at around 2/3 of a knot, 1/3 of a meter per second. Booms towed or placed at right angles to currents of over 1 knot are therefore likely to fail. To a certain extent, this can be overcome by deploying the boom at an angle to the current. The boom can be angled in such a way that the velocity of the currents at right angles to the boom is reduced. This decreases the forces on the boom and prevents the oil escaping. Booms have been known to break away from their anchoring points, so care has to be taken when determining boom positions and calculating the forces on them. There are well-proven calculations for doing this. When a boom is anchored, it is important to provide additional flotation at the mooring point to prevent the boom from sinking. Also, where water levels change, a compensation device should be used. Constant attention to the boom throughout its deployment is essential.
Contained oil must not be allowed to build up. Recovery can be achieved by using skimmers, sorbents, or sheer manpower. Sorbents, either natural or man-made, can retain oil. Whatever is used, in this instance coconut fiber, it has to be collected. The use of sorbents can be effective for small spills or for final cleanup of trace amounts, and to remove oil from areas inaccessible to skimmers. A skimmer is designed to recover oil or oily water mixtures from the surface of the water. There are many types of skimmers, but however they are designed, they normally incorporate an oil recovery element, some kind of flotation or support, and a pump to transfer the collected material to storage. Adhesion and suction are the two basic principles of recovering oil by skimmers. Adhesion skimmers can operate using belts, discs, or mops. A variety of ways are employed to provide suction.
All skimmers, apart from oleophilic mops, are sensitive to debris and waves. These mops are driven by rollers, which also squeeze out the oil. They're also able to cope with a wide range of oil types. Disc and drum skimmers operate by scrapers, removing oil from collection surfaces. The oil is then collected in a sump and pumped to storage. Such skimmers tend to collect a high ratio of oil in relation to water. Most are designed for low to medium viscosity oils, although this one has a set of 4 vertical toothed discs and is able to recover highly viscous oil. Weir skimmers operate by oil overflowing a self-leveling weir and are also primarily intended for low viscosity oils. But weir skimmers, which incorporate screw pumps, have a high viscosity tolerance. All weir skimmers tend to collect a large percentage of water and so need to be used in conjunction with sufficient storage capacity to allow the oil and water to separate. Air suction skimmers can sometimes be operated in quite difficult sea states. They collect high percentages of water, which facilitates flow, reducing the possibility of hoses becoming blocked, allowing high viscosity oils to be picked up. There are a variety of skimmers available. Some are self-propelled and some are incorporated in boom systems. The most appropriate should be selected after an assessment of the type of oil to be recovered, the ambient temperatures, the sea conditions, and their versatility. The availability of adequate storage for recovered oil and water can also be a limiting factor.
In the event of a spill, its location, the weather and sea conditions, as well as the amount and type of oil, will determine the appropriate equipment and techniques. This crew have decided to use a boom in a U configuration in order to sweep the sea surface and collect the oil. The problems of coordinating more than one vessel to recover oil at sea are severe. In the varying winds and currents, even skilled seamen can find it hard to maintain the required formation. It's difficult to keep booms and skimmers in the correct positions relative to the oil, unless vessels with sufficient maneuverability at slow speeds are employed. Even if such vessels are available at short notice, the area that can be covered is often only a fraction of that affected by oil. A single vessel may perform the multiple roles of oil containment, collection, separation, and storage. These vessels can have large capacities for the storage of the collected oil, and some also have the advantage of being multi-purpose vessels. In this case, a buoy tender has been equipped for this role. A number of systems have also been designed to operate from ships of opportunity. Netting systems have been developed for viscous oils. These are easier to handle in the water than conventional booms, and so longer lengths can be deployed from the recovery vessel using a small fishing boat. Although a single ship system is more maneuverable, it has a very narrow sweep path. This disadvantage may be less significant where the oil is driven into windrows. Because of the limited sweep path, it is important to operate single ship systems in areas where the oil is thickest. This is not easy to determine from the deck of a ship. As with all recovery operations, a control aircraft with good communications is essential. The more quickly oil can be contained, the less area it will cover. But however speedy and effective containment at sea, oil inevitably reaches the coastline. Successful recovery operations can frequently be carried out in coves and other natural collection points. Debris also tends to concentrate in such areas, and it's likely to interfere with the performance of mechanical skimmers. Booms and skimmers have an important role in protecting vulnerable coastal resources. Whilst operations are still progressing at sea, preparations are made to protect sensitive areas of this coast. It's not always possible to protect all sites. Careful planning and the early identification of priority areas for protection is vital. Here, a fixed mooring has been installed. Such has been the priority. Other areas have been deemed inaccessible or impractical and reluctantly left unprotected. At this point, as the estuary is too wide and the current too strong, this team have decided to deploy a staggered configuration of booms further upstream. Here, the current is still in excess of 1 knot, but with correct mooring procedures and by placing the booms at an angle, some of the oil can be deflected for recovery. Constant checks are made on the configuration of the boom as the wind, tides and currents change. The mooring is being adjusted here as a result. Short sections of boom can be used to contain oil washed from shorelines to assist oil recovery. Small spills can often be tackled successfully, but no large oil spill is ever likely to be completely contained or completely recovered. Equipment should not be left out longer than necessary. It must be cleaned and made ready for reuse without delay. Equipment can be cleaned with steam or dispersant, provided they don't cause damage to it. Before storing, all necessary repairs to equipment should be undertaken. In addition, regular maintenance schedules should be drawn up. Once cleaned and overhauled, equipment has to be stored. Heat, damp, pests, and poor ventilation can easily render equipment and materials useless. Money and effort spent on secure but accessible storage, with these points held in mind, can often pay long-term dividends. Training and practical exercises are essential. Even the deployment of booms under controlled conditions and fair weather without oil will highlight some of the difficulties and provide local crews with some skills and insights. Controlled exercises can help personnel develop new skills. Here, a trainee is shown a simple method to attach a boom to its buoy. Besides new skills, it's also vital to rehearse the basic principles of seamanship, such as small boat handling and tying knots. Not all teams have the advantages of sophisticated equipment, but the principles of oil spill cleanup are similar throughout the world. The key to a successful response is quick action to prevent the movement of oil to sensitive areas. Well-maintained booms and skimmers deployed at the right time in the correct conditions can be used to protect sensitive areas by deflection, containment, and recovery. Well-trained response teams who understand the limitations and capabilities of these systems will undoubtedly use them to their best effect. Spill occurs, there are four main approaches: natural cleanup, containment and recovery, chemical dispersion, and shoreline cleanup. In many cases, a combination of all four will be required. This program deals with shoreline cleanup. The place where sea meets land. Our planet's coastline. Miles and miles of varied shoreline, from rocky cliffs to mangrove swamps. Each coastline will have a different character. Some will be desolate, some the home for wildlife and fisheries, and others the location for amenities,